Okay, yes, sir.
Good afternoon, sir. So our topic for today was data mixing that we were given a benchmarking. So we prepared also I and you were prepared to topic of papers, one on benchmark and another on first benchmark and another on alignment, and Ayush also prepared a paper on alignment. So we have three papers. So the first paper is on MMLU, which is a benchmark for language models. You
Come. Wait.
So this is the first benchmark. Uh, so yeah, why? So first of all, moving on to previous NLP models and the benchmarks. So what was missing in that? So now modern NLP models are creating benchmarks like glue and super glue. So basically these models basically test the language understanding and common sense knowledge. They do not test the conceptual understanding of the subject of different subjects uh, that is mentioned here. So there was a model that judges the model on there was a need for benchmark. There is a model on build application and the knowledge in different subjects. So yeah, before MMLU, before moving to MMLU, first let us know about pre-training evolution. So mostly modern day NLP models are pre-trained on massive formula, like Wikipedia books, web rated, etc. So due to which they gain diverse wide knowledge and they can answer basic like basic physics question or a basic elementary question of each subject. However, they cannot. There was not there wasn't a benchmark to judge the application skills of that model. It is also mentioned here. And another thing, previously benchmarks used to do fine tuning for assessment, but that led to means that was that took more time and uh, no, and we are here it has we have realized too short training. Like we have not done fine tuning. They have not done fine tuning. They have given few shots to the model and then they have said the model. Uh,
One thing I would like to add is in this graph you can see that ChatGPT, according to the even not glue, even when the super glue benchmark came, that performed like almost 75% accurate with 75% accuracy. But eventually, what MMLU would tell you is basically it's a newer benchmark and it would actually tell you the story how actually good ChatGPT 3 and even its largest models. So eventually, we'll get into that.
yeah, the limitations of existing mentors. So, like these are some common benchmarks which test basic common sense knowledge with basic knowledge we have, and there are some newer data sets and which focus mainly on reading comprehension and school level knowledge. So where all these benchmarks were short that they do not reflect professional level and subject specific knowledge. It was actually given and uh, basically application part is not assessed in that model.
So you're saying basically they don't test reasoning much.
Yeah, exactly.
I have this discussion, right? You're presenting MMLU.
Yeah.
Right now, I'm motivation for MMLU, right?
Yeah,
You
means
suggest the existing benchmarks.
they can answer. For example, they know a fact, but they cannot apply a fact to a real world.
So basically, the existing benchmarks, they are not actually testing your like analytical skills, and they are mostly focusing on the knowledge part. And because of that, ChatGPT 3 was already able to perform superhuman levels. Okay, so
So yeah, there was a need for agriculture. So yeah. So now coming to what is MMLU? So it is divided into 57 diverse tasks.
so your presentation is relevant for cognitive response.
So it is divided into 57 diverse tasks spanning STEM, humanities, social science, and other domains. And it is also inspired by real-world exams like GRE, USMLE, AP, and other university exams. So these are the dataset statistics. So there are around 15,908 questions, and there are few short definitions, verification, certain tests, and the categorization of questions for each certain given. And there are also categorization of difficulty levels, elementary level, high school level, and college level, and professional level. And it is of the performance of this is compared to both a normal human and the expert level in that field. Uh, like for example, expert level here it is determined by the guy or the person who has scored 95 percentile in that exam or in that university exam. So that came out to be around 89.8%, and a normal.
You're not describe the task. I think.
We'll, yeah, we'll that will come further the type of task we will be giving. But this I'm just comparing the human performance in that random human which has
These are not multiple choice, right? All of them are not multiple choice.
all of them are multiple.
So then where is the reasoning part?
So
I thought the whole motivation was to get.
no, but for example, I'll show you the question. Like these are some questions, like physics question and like different question in the set of points for this one. So basically, it has to make program, it has to analyze the question and solve the question. It's not a factual question. It's like some sort of like JE question or that question in which some sort of analysis, it is a conceptual physics question.
So by virtue of the toughness of the question, there is reasoning. This all yours.
Yeah.
Yeah, exactly.
Yeah, MMLU, I mean, the questions themselves require reasoning.
Even though they are multiple choice, even though you can get 25%.
Yeah, that is a baseline that even a random guy can get.
Always 4 options, is it?
Yeah,
Yes.
always. We'll I'll discuss that also.
And also to tell you about the difficulty part, it is estimated expert accuracy. This isn't that the guy would be knowing everything about that subject. It's just that he's an expert and he has gotten like 95% of the knowledge. But even with an educated guess, he would be able to score 90%. So that is the
An expert, educated expert should be able to do right, is able to get it.
So for example,
So it's not that difficult.
no, for example,
The reasoning in MMLU is not so difficult, right? MMLU, you are saying estimated expert accuracy is 90%.
no,
Yeah.
for example, if a physics question is asked, so a physics expert would get the accuracy of 90%, but if he is given a chemistry question, which is not in his domain, then he would score accuracy of 24.5%.
So just in case you think that this isn't a very good database of questions, the score that we see this or GPT-3 and the largest model performing all these data sets, they will actually give you a more accurate idea of all these.
So this is the diversification of different types of subject, STEM, humanities, and told earlier, STEM, humanities, social sciences, and other like professional medicine and global facts. So, so these are some examples which I've already shown you: economics, mathematics, medicine, conceptual physics. So basically, it is a bit of analytical and conceptual knowledge. So yeah, these are the models which we evaluated. So firstly, they evaluated GPT-3. They did few short prompting for GPT-3, and in that also they varied the size of different models. They did for different models of different size, small, medium, like large, and extra large. And we also we used unified QA model. We did zero shot transfer, but we have fine tuned it. For this for GPT-3, we are not fine-tuned for unified QA, we will be fine-tuning it. We get QA data sets like Spot and Race. And there are additional models which we have used for comparison. We have not done detailing in that. We have not gone into detail in that. We have just used them for comparison. So yeah, now how we have given how we have done prompting in GPT 3.0. So it is basically a multiple choice question. We have given the question and it has to answer a single token like so we have done a few short prompting fixed website with 5 short examples per subject is used across all of it. So for all the subjects, we have given 5 questions or 5 short examples for which we have done the prompting with the model.
Okay, so this was the result that we got, average weighted accuracy across all the 4 domains and the average of it. So like what you can see here is these 4 models and even the chart GPT, sorry, the GPT-3 small, medium, large models, uh, the, the average score they got was around 25%, and that was the baseline. As you said, that was the score that we could have guessed only, right? So even on that data set, they just like the performance was just average and it was just by fluke, as we can see. But
Which model? Which model?
for these 7 months, it was almost by fluke, as you said, like 20.
It was GPT.
No, no, yeah, the these GPT saying that it's the leaving the extra large model, all the 3 models were around 25.
So
Have
like
you been evaluating on the MMLU? This seems little problematic. GPT score won't go so low.
But you have been evaluating MMLU also, right?
These do not go so low generally. Even 8 billion models perform somewhere around 35%.
in what on what data?
It's a zero. MML.
Zero
Zero.
Yes,
You can check.
this was
You are listening to
this was the data we completely got in the website.
so like would it be fine if I show you the research?
Yeah. No, it's okay. We can discuss it after.
Yeah, and this one thing with we take into account the unified QA model is smaller than the GPT-3.
So according to the research paper, these 6 models did like they were almost working on full, and ChatGPT 2 was a little bit higher, and these 2 were the main guys in the competition, and we would be seeing how they perform in the further steps.
See, Llama in a zero shot setting has as much as 66% for him.
So that must be after fine tuning on.
Llama based.
Like, since from this table was directly taken from the
We can show the reference paper.
That's from MMLU paper you're putting there.
Yeah.
Okay.
We can use the paper.
You can do that. So we just made a graph out of it, and you can see most of them were almost near the baseline, that 25% mark, and only Unified QA and ChatGPT extra large models were performing a little bit. So what exactly did we do with them? So GPT-3 was like was given a few shots, and Unified QA was done, like fine tuning was done on them. What the interesting thing here is, GPT-3 has 175 billion parameters, while Unified QA only has 11 billion parameters. So on the average accuracy for Unified QA was better. So you might be thinking why that is happening. So that is what is.
Can you show what is unified QA? Just the architecture of the unified QA. Can you go back to unified QA?
I don't think we have the architecture.
You know, you're not presented somewhere. I mean, at the next built on T5. Quad and raise it was actually the class with raised to know that in general.
Basically, the data set that Unified QA was initially trained was on only question and answers, unlike ChatGPT, which is trained on like general data. So basically, this.
What is T5?
Yeah.
You see, I mean, this can you open the original MMLU paper? It is difficult here to understand. Unified QA does better than
like, do you want us to?
No, no, no. Can you open it separately? You know what you go ahead.
So, what was interesting was even the smallest unified QA variant, which just had 60 million parameters, that also performed 29.3%, which was better than, which was not better than, but almost equal to GPT tools.
This was a large GPT model with new labs. This was also. We have limited silence for GPT, but this is only one. So
For GPT.
for GPT.
So the key conclusion here is model size is a key component for achieving strong performance that we can see with GPT that is performing very well compared to these three GPT models. But fine tuning also helps. That is the main thing that we wanted to present here.
This was 19.
A unified QA was fine tuned and GPT-3 was just few shots. So for all the 57,
It's possible, right?
So before this saying the paper is of 2021. So the GPT-3 used here may not be the GPT-3 which we are aware about on the website. The knowledge distribution Prashant was saying will be really different.
Okay.
so
We have two
the
papers.
so there were 57 subjects as we initially told. So on all the 57 subjects, these were the like these are the bar graphs how GPT-3 and unified QA perform. So you can see there are some fields in which unified QA is better, while there like GPT-3 also performs better in some other cases. So here's the interesting thing: GPT-3 performed the best on US foreign policy, although like unified QA performed better on marketing. So the general trend was basically both the models performed very poorly on STEM subjects, where even a little bit of thinking is required.
And moreover, where calculations are involved, there both the models perform poorly, like maths and physics. And
Math and physics, where both the models were.
where calculations are involved, where the problem has to be solved in steps.
Even more procedural than.
Yeah.
So basically, MMLU is trying to show us that glue and super glue, they were almost these GPT-3 models were almost performing at superhuman level, but here they are even they are performing bad, like worse than expert level performance. So this is a very good prompt, I guess. The prompt given was the order of operations of pandas or bottomless first. So GPT-3 like replied in a very good sense, like the prompt was complete. But as soon as we asked it a question about the same thing, it actually gave the wrong result. So why it
Operations in GPT-3 is parentheses, exponents, multiplication, division. Yeah, but this is fine.
This is fine, but when we ask it actually something very easier on a mathematical question, it just got us the wrong answer.
It has knowledge of what is this, but to apply it, it failed. Means it was unable to apply.
Not able to apply the knowledge that it already has. So that is the conclusion. And for GPT-3, 9 out of 10 lowest accuracy task were STEM subjects. So this was the main conclusion of these 57 subjects. Mainly in mathematics and all, it performs very poorly, almost just touching baseline, 25%. While in the like where the subjects are more or less in favor of just knowing the knowledge, it performs very well.
And one more last thing, it also GPT-3 also.
But you didn't talk about reasoning much. So this is all the guys.
So it's a 21 people. So even chain of thought had not by them.
Okay.
Even
Good that you're here.
GPT-3 also performed poorly where laws and ethics were involved. Like,
Actually, that question happened. Actually, the system.
like
I think I got it. I mean, I think we're getting this.
So yeah, means
So laws and ethics are possibly still trainable, but their
yeah,
inference there is slightly less required in math and.
Yeah, exactly. Yeah. They're not as bad as in.
Okay, so.
that's our even our next paper is on alignment. So that would uh, yeah. Then coming on to calibration, the for all the 57 subjects, this was the graph for accuracy versus calibration, and it was we gave observed that during time of 2021, GPT was poorly calibrated. Like for some subject, it had like for marketing, yeah, it was around it was even less than 60%, and it was around 20 to 30% for most of the subjects, and it is zero shot calibration. Uh, when we did three shot prompting, prompting, then it improved, and the results were like this. So
What calculation mean?
means the confidence interval of the you might like say if it is 20% like basically it's the confidence interval like 20% only 20% time would be if the answer would be correct. So that
Exactly, we want if the GPT's answer is correct, we want it to be confident.
Yeah.
So that is the calibration.
yeah. So it was observed that on after prompting the calibration becomes better and the confidence interval also improves. So yeah, then model limitations. So yeah, this is again I have mentioned that in case of professional law and moral scenarios, model has low accuracy.
Yeah, yeah.
Yes. So
Don't keep doing, I mean, why don't you proceed?
yeah, and then there is an improvement. Yeah, conclusion. This mostly we have covered. Models are uncalibrated, but yeah, it has exactly. So this was the paper used. This was the second paper which we.
So this research paper was published by Anthropic. And so let me just start from this. Basically, it wants
Do you know what?
that alignment. So the alignment is helpful, honest, and harmless. So the more of the ethics part that we talked about, this is trying to fix that. So these traits are measurable through diverse prompts. So that's the thing. And then why is it important? Because AI actually how AI behaves in the real world settings. And why does it matter? Mainly risk and like, because as the world is growing, AI is growing on stuff. Okay. So the first thing that could fix it was prompting. What prompting is, basically you give it a prompt like RAG or something, and then you ask it questions similar to that. So basically that the pre-prompt that you give is more or less polite and structured data. So GPT would try to copy that in its response. So that is what we are trying to see here. So that graph will explain later. This one is basically as the number of parameters were increasing in our model, the accuracy for these three or four criteria it were going up. So that basically is just generalization. Increasing the size would generally increase the three that we are concerned about. That graph would be like our data.
So yeah, we will be covering both the classic evaluation part. It was just going for inclusion, right?
So the next is fine tuning. So what the disadvantage of prompt method was, prompt actually uses up some space in context window, right? And then it limits the prompt length. So you cannot give like too long prompt because the pre-prompt has already taken up some space and it wastes computational power. So what alternative was presented in the paper was fine tuning. So we can fine tune the model on whatever the pre-prompt that we were planning to give. But the main problem behind that is, uh, let's say our model distribution is like P of x, and the context is C. Fine tuning, what it does is it brings P of x closer to P of C, right? That is what fine tuning does. So basically, we have a fear of slight overfitting because maybe what if the context is very small and all its knowledge, like all the P of X starts shifting too much near P of C. So that is one of the issues here. While prompting, what prompting does is simply P of X given C. So one more example that was provided that I found interesting was, let's say you have a sequence from, you give the prompt sequence from 1 to 63. What fine tuning would do is, it would keep repeating that thing, that the prompt is 1 to 63, 1 to 63, but it never tells the model to print out 64 and 65. But that is something which is better in pre-prompting. So both have their pros and cons. So what the paper is presenting is context distillation. It's a sweet spot between the two. So what it does is it provides us with a loss function, which is just k divergence of these two quantities. The first one is how original model would have. This one is how the model would have performed without a prompt, and how this would have when we would have given it a pre-prompt, only the pre-prompt. So like seeing the KL divergence, seeing how the two are differing, that is a loss function. So that basically fixes both the problems that I showed you in the last two slides. So what the interpretation they gave was, we want the new model to behave as if it saw the prompt, but we are not giving the prompt at the runtime. So that is how context distillation fixes it.
Yeah, now moving to
We'll
the
go back to the previous slide. Basically, your approach is distillation based on you're distilling from the non-conditioned, right? Oh no, your P theta X is the distilled models also. But which is distilled? Distilled is which from the XLC is the from distilled model or X is the distilled? Which is the distilled?
So like this one is
So P
distilled.
theta X is distilled.
Yeah. So we just asked it about the answer for a prompt, and this one is on for the pre-prompt was. So we are just trying to see the loss function there.
Okay, got it.
yeah, now for all
I was just thinking even for projects, right? Knowledge graph, like instead of C, you put a knowledge graph itself. So how do you make a model view through the lens of a knowledge graph? One is provide the knowledge graph as a context, and then try to distillation.
So that's what I think we are using the knowledge. And we are fine tuning also, but we are putting an explainer component in between because the triplets cannot be directly used. They are getting into a structured format, but you can say
That's for conditioning. That's like the prompt only, right?
no, we are fine tuning on that's our training data.
We can discuss this. Yeah. So
now we'll apply the techniques to model and check the benchmark scores. So first is HSH evaluation and full QA. So these two are evaluation. So the setup for both evaluation is given. Pair comparison across grade. So these are multiple pair-based questions. Uh, so yeah. So next slide. So yeah, note one thing there is this HLS evaluation uses empirical mutual information instead of mean total probability. What is that? I'll show in the next slide. So yeah, it's basically how related your answer is to the question. So for example, my answer is completely independent from the question, then technically it is not that helpful the first for the first stage. So yeah, this is again the probability of getting that answer, and that query Q stands for query, and it is defined as log condition probability. So it will become zero when they are completely independent, and it will maximize when they are quite correlated. So we have to maximize this function so that the answer is more helpful.
so they use scale divergence, right? Not mutual information. I'm a little confused. I was saying why mutual information? They use scale divergence, right?
No, this is not this is the property of the benchmark model, the HLS evaluation model. That is, we are doing something on the our GPT and the language model. So this is the property of benchmark model.
What's the property of?
Yeah, this is I think the evaluation setup. So there was a so there is a model that evaluates the language model on this. This is property of benchmark. It's that one.
So what is the property of?
That if this it evaluates on basis of this mutual information that how helpful is our model.
How helpful is your model given?
So we have so basically it returns a paragraph on basis of a question. So then it evaluates the mutual information of that. So the more is the value of the mutual information, the better is the more helpful is the our model which we are using language model. That clear divergence was the technique we used for the last.
But what is A, what is Q? I'm not understanding anything. So what is A, what is?
So, for example, we have a model. We are
No, tell me with respect to HHH, whatever data set. This
So-
was not for HHH evaluation, right?
so it is a benchmark it's evaluation and it is a setup for that how it works. It is a benchmark model. We are
You didn't describe what is HHS in the first.
So
place.
you understand what?
It's a preference data set, right? If I'm not wrong.
no, it's not a data set. It is a means it is a benchmark used for evaluating the
Helpfulness.
helpfulness, harmless.
So sir, any response, it can be scored on helpfulness, harmfulness and.
That understands what are A and Q.
So A and Q is the probability of getting a particular answer. P of A and Q is the probability of getting that particular query. And if they are interrelated, so their conditional probability would not be zero. It would be some value. It would not be one. For example, this whole value would be one if our answer and query are completely independent. They would be independent events, and we do not want that. We want our model to be helpful. It should be related to our query which we have given. So if it is less than one, so the value of I would be great. If it becomes zero, it would be one, and if they would be related, then it would be greater than zero. So that we want we want more value of I, so that our answer and query are more interrelated.
So basically, it was like some entailment. It's not related, right? It is an asymmetry, first of all. Don't say related. It's mutual.
Means probability
Is it symmetry? No, right?
but means the probability means they both should not be independent. Our motive is that the probability the A and B must not be independent.
This is what is used for entailment or measurement in the HHH.
Yeah.
So it's the same measure for H. All the three H use the same measure. Nothing changes.
So why would we want them to be like, why would we want this function to be symmetric? I think it.
That's okay. It's not, but don't call it correlation. No?
Okay.
The same correlation again. So my question is this the framework is about identifying how much does how much does Q or A implies an answer to Q. Right. So this is just a framework for relating answer to the question.
Yeah.
And this is used for all the three H. First H uses the second H uses the third H uses.
So there is a model made for all the three H, and it is a part of that.
So the same I is measuring all the three H.
No, it's for helpfulness.
It's only for helpfulness.
Yeah.
What about harmfulness? There's some other measure.
Yeah.
But you're not written, there's no connection between this light and helpfulness.
Means there was a point when that model was mentioned in the paper. It was it said that it uses mutual information, and then they had described mutual information because it was a new term. So that was the reason they have described. Like for truthful QA evaluation also, they are just like that it is based on multiple choice question. They have not told us what is the structure and that of the model in the paper. And similar is the case for this.
I'm not understanding. This is the same measure used for all the three H. Can you answer to the point why we beating around the bush? Is the same? Is this a combined measure of all the three H? But it's a separate measure for each. I'm not understanding. your
It's
answer.
not a combined measure for all the three.
Mhm.
But
So there is different. That is a measure for helpfulness only, and there's a different measure for harmfulness.
that was not.
Which are the other measures?
That
Uh-huh.
Like, does the framework change or is it the same?
no, the framework does not change, but means I'm not sure about that.
Yeah, so you have to spend time understanding the paper.
Means it was these are independent different papers. SHG evaluation. There is a different paper for that, and there is a different paper for this also. We have just used the results here because the thing which we want to compare is that the complex distillation or prompting, how does it affect the benchmark scores in that. So our objective in this paper is to compare that. This is just a piece of information which was given in our paper, so we told that. So yeah, means this was the graph which was told earlier. So yeah, these were the scores for honesty, helpfulness, and harmlessness.
I mean, I don't know, we're able to connect anything here. You showed only one measure. I don't know what is honesty, what is helpfulness, what is harmlessness. It's coming from the sky. All these are dropping from the sky. I mean, do you understand what you are
So
presenting?
basically, there is a benchmark model that evaluates our model accuracy on and it gives a score of 3.
That accuracy is unknown, that model is unknown, that the three are unknown. Oh, everything is unknown.
No, the
What
model,
is known
the
here?
model is again the GPT 3.0 and the Cloud version.
That's not mentioned anywhere here. What is
That's not even that.
what is accuracy? What does accuracy mean? What does honesty mean? What is helpfulness? I mean, you have only shown IA, Q. What is where is I keep A, Q here?
Means like we have a language model. We have applied some techniques on that. We have done computing or something. We want to compare that how the number of on increasing the number of parameters. Like if it
Why you're taking tangents? As you increase the number of parameters, where is IA, Q on this slide? I'm not understanding the connection between your slides. They're very, very different slides. You pick one
means
one paper, another
okay,
slide from another
you
paper.
can for now ignore this slide. Means
But then what are those measures? How can you go back to the next slide? Then what? I'll ignore this slide. Sir. No, next. What are those three curves? What is orange? What is green? What is how are they measuring these three?
so these are the benchmark scores for the model, for different models, and these are the parameters of that model. And one implies that it has means it is completely, I guess say for first it is completely
Okay, there's a distal mutual information. There's some mutual information sitting based on IA, Q. But you're not able to explain the connection, right? Okay, I think we should proceed. We are spending too much time and not getting a hang of what you're presenting. There are some three different benchmarks for honesty, helpfulness, harmlessness created by three different universities or three different universes. I mean, just GPT is being evaluated on three different data sets on the same graph. Is that fair? How can three accuracies? I mean, what do I take from these three accuracies?
means
There's a honesty benchmark, there's a helpfulness benchmark, there's a harmless benchmark.
means we want to hear from that we on increasing the number of parameters, the model performs better on.
Oh, I mean, that will overfit. Why can't we show the train test? Why can't they show AUC? You have to critique also the work now.
Means,
Okay, I think we are wasting too much time. And there's a mutual information sitting here, but you have not explained the connection of mutual information that I came out. What is mutual information? LM mutual information. You don't understand this.
So it is language model. Means
What is this distilled mutual information?
What actually happened was there was no mathematical like calculations or any formulas in that like research paper. What they wanted to show was this is how the model performed earlier and after that thing I showed you here, the context distillation thing. After we did that, how the mutual information that shared was better in that.
So this measure uses mutual information, but the distillation uses the context-based distillation. Is that what you're trying to say?
No, distilled is can you repeat the question?
The distilled is based on the distillation model. Mutual information is a measure being presented.
Yeah,
Okay.
exactly.
Let's move on. What is the take home from here? What is the takeaway?
means after doing that the
Basically, I showed you two methods like prompting and fine tuning, and I showed you a sweet spot between those two. So basically,
Using
applying that,
distillation is helping improve.
exactly.
On the mutual information. It maybe it's a cheating. We have designed some information function, mutual information or measure, which is helping them. I can come up with my new measure called Ganesh measure. And I can say that, oh, I'm doing very well on Ganesh measure. How are other algorithms? What do others? I mean, is it consistent with other measures like accuracy? So a little bit insight, right? We need to understand what is going on here. Okay, next.
Means, another, that was toxicity. So again, it was again a benchmark for evaluation. We used 1,000 prompts from real toxicity from data set. And then we measure toxicity using an automated detector. And we compared the unaligned model, those with prompting, and we compared the prompt one and the context distillation one. And I'll show you the key observations what we observed. So, for example, when we trained with non-toxic prompts, like we were just having a normal conversation. So then we evaluated the model. Then for a prompted model and the context distillation, both cause a different toxicity as the number even as the number of parameters increase. First of all, you can see the
Fine. I think the graph is very good. Okay.
and again for this also when
So left is without toxic prompts and
yeah,
right.
and when we have so again without prompting and
But there's a lot of oscillation when you have toxic
uh,
prompts.
because when we are training with toxic prompts, the toxicity decreases as the size of model increases. So this is the insight from the here are prompts
Got it.
and context distillation then. Yeah, again, another was human preferences and model performance. So here we were comparing two models, and both were and a human was comparing which one is again better head-to-head comparison between two models. Like for example, a model gave a answer to a query A, and another model gave B, and a human would be choosing which one is better. So again, here, as the number of parameters increases, obviously it was obvious that the so the score which we used was Elo score fit. That is same is used in chess to compare the rating or skills of two players. So to compare the skill, we were using a Elo score. So so the shape was becoming like a plateau. It was increasing as the number of parameters were increasing. That was obvious. The model was becoming better, but it saturated at some point. Another key observation was that for the same model, for the model with same parameters, the model which was context distilled and in which we have done short prompting, the score has dipped a bit, like you can see here in both the cases. So this was the observation from for this evaluation. So here our context distillation and prompting is not helpful. We can see that. Now another is now when we have done the alignment, there the overall performance of the model is we have to judge that the task performance has changed or not. So that's basically very that only that gives difference in accuracy without alignment and that. So when we evaluated that, we observed uh, initially for smaller number of parameters, yeah there was a dip in the performance, but when the number of parameters increases, it helped us. Alignment helped us, and the number of and the performance bettered after invite. So it is basically instead of tax, it acted as a bonus. So you can see here, even here also after some point of time, the prompted and the prompted one will have is performing better. So this was the influence from this lower models when that alignment is not that beneficial, but for larger models it is helping. Yeah, so this was the paper link for the paper. So these were the
Is that third paper?
so these were the paper. These two papers we do prepared, and there is another paper.
Okay. Right.
Right.
We are out of time, and actually I have not done a thorough research. So it will be better.
So you will present it. So what is the project?
So basically, it is like we were initially added to the data mixing group, and then Bhuvneshwar asked us to contact Durga, and then Durga wanted us to perform in that subgroup, which has benchmarking. And basically, our main goal is checking benchmarks of various different models. This is what was told to us. And the initial paper that we showed that was provided by Durga, and the second paper was provided by Bhuvneshwar.
So what is your project?
We have to, evaluate benchmarks for different models and then justify which one is better for and why.
So you are aware about this. Storage is also part of it. So can you explain also what you are?
So we have to compare benchmarks for different models and justify things that why it is performing poorly in this and why it is performing this. And he has given us like each of us rated
Different types of benchmarks.
different types of benchmarks.
And then he wants us to take basically two different models and see which model does better in this particular benchmark.
That's like really simple, right?
But that is all work already done, right?
That lot of benchmarks
That is what we asked them. We wanted,
Can you discuss with English?
but they said they basically we asked them the same thing for so that this is quite like simpler.
So can you get back? Because this is something you have been already looking at, right? So just talk to Suraj also once. If there are some non-trivial benchmarks, for example, MMLU as we have been doing. But if we can do the non-trivial benchmark, unless for non-trivial benchmarks, maybe that could be a tool.
like you can come and find out benchmarks.
What is P? What is P?
Let me just show you that.
Like new benchmark that.
We are not given our project is not on MUL. We are
No, not exactly. So these were the filters what they wanted us to. They
These are on data sets.
data sets and that is what we discussed and they gave us that paper to read.
I would suggest there are many benchmarking frameworks. For example, how do you detect hallucination? So that has a non-trivial framework for hallucination detection. You should also, because these are pretty straightforward. I mean, you
That is
change the
what
data set.
but they said that is the only process that is available. Is that so much argument. So
My suggestion would be that there are many qualitative evaluations like hallucination evaluation or of the perplexity score. Because beyond perplexity score, also have a model when it is responding in paragraphs then without making sense. You should look for some non-trivial evaluations there.
Yeah, that would be helpful. So non-trivial evaluation would be.
So for this, this should be taught in Java
But keep Suraj in the loop.
So you can contact them.
Sir, can you send an email to them 16? Is there a group that you always part of?
Yeah, what's it?
Just add Suraj to that.
Yeah,
Makes sense. Yes, take it. Okay. Okay, Pratik, anything else or we stop there, right?
Yeah, I think that's all. I don't have anything else in mind.